There we go. Okay, so for unit 9.5, we have already gone over parabolas and circles. Okay, so today we're going to work on a new shape, and we are going to find the vertices.
Can I turn off the lights?
There's one off, but I can turn off the other one, yeah. Find the vertices of an ellipse and sketch. Find the vertices of an ellipse and sketch. So last week I told you guys that you have to make sure that you don't draw your circles too oblong or rounded, or excuse me, too egg shape, because we are going to go over something called an ellipse today, and that's more like an oval or almost like a football shape. Okay, so the formula, general formula for an ellipse is x minus h squared, in parentheses squared, x minus h squared over a squared, plus y minus k in parentheses squared over b squared equals 1. Okay, so x minus h quantity squared over a squared plus y minus k quantity squared over b squared equals 1. You guys all see, or do you want one light on? One light. Okay, so first thing you need to know is that the center, if you had to take a guess, where do you think the center comes from? Just like in a circle, where does the center come from? The parentheses, the h and the k. Okay, center comes from the parentheses h, comma k, and you will change both signs of whatever was in there. You also need to know that there are going to be two radius here. Okay, so the radius, remember, is just how far you go from the middle of something or middle of a shape to the edge. Okay, there's actually going to be two different radiuses here. So you need to know that the x radius comes from square root of the x denominator. Okay, so the x radius is going to come from the square root of the x denominator. So you're going to take square root of the x denominator. The y radius, so I'm sorry, when we go over the x radius, which way is this going to tell you? Would the x radius tell you how far you move side to side or up and down? X-axis is side to side. Okay, side to side. So basically how far you're moving left and right. The y radius comes from the square root of the y denominator. So the y radius is going to come from the square root of the y denominator. And what would the y radius tell you? How far you go up and down or side to side? Up and down. Okay, so these are going to tell you up and down. These are side to side. And this will become a little bit more clear, hopefully, when we actually put in some numbers. So all of your questions today are going to ask you to identify the center, the vertices, and to sketch. So when we went over a parabola, how many vertices are there in a parabola? There's only one vertex in a parabola. Okay? This is the plural of a vertex. Are there any vertices or edges of a circle? No, because it's round. Okay, so you can't tell me which are the edges because it would be everywhere. Here we are going to have two different vertices. Okay, and you'll see where we get them in just a second. So for example number 1, we're going to find the center, the vertices, and sketch of x minus 2 squared divided by 9 plus y plus 4 squared divided by 25 equals 1. Okay, you'll also notice that all these equations should equal 1 before you can do anything. So first thing we want to find is the center. Okay, center is going to come from h and k. Okay, so from -2 and +4. What do we have to do when we take out the center? Change the sign. So what would the center be of this of this ellipse? Excuse me. 2, -4. So center is at 2, -4. So I'm going to go ahead and draw this at the same time. So 2, -4 means right 2 and down 4. So over 2, down 4. That's your center. Then we're going to look for the x radius. Okay, x radius tells you how far you move left and right. Okay, so x radius tells you left and right. And what is the x radius going to be equal to? X radius is the square root of the x denominator. So square root of 9 tells you you move how far? 3. So from the center, you're going to move left 3 and make a dot, and right 3 and make a dot. So move left 3 and make a dot, move right 3 and make a dot. Now, also when you do this, when you're moving, I want you to label how far you went. So just label 3 and 3. I don't need you to label the points. I just want you to write how far you went. So you moved left 3 and right 3. The y radius tells you how far you move up and down. Y radius tells you up and down. And that comes from the square root of the y denominator. So square root of 25 tells you to move how far up and down? 5. So from the center, from here, you're going to move up 5 and down 5 and make a dot. So move up 1, 2, 3, 4, 5. Make a dot. And you're going to have to add some dash marks, probably. And move down 5 and make a dot. Now, to figure out where the, then we connect these. Now, you want to connect these with like an egg shape or an oval shape, not a diamond. Okay, so try to not make really pointy edges. These should not look like diamonds. They should look more like eggs or ovals. Okay, this is called an ellipse shape. Then to figure out where the actual vertices are at the ends of farthest distance from center. Vertices are at the ends of the farthest distance from the center. So basically you label these so it tells you which one is farther away, the side to sides or the up and downs. The up and downs, they're 5 away. The side to sides are only 3 away. So you label these two as the vertices. So what point would this be at? Over 2, up 1. So this vertex is at 2, 1. This one is over 2 and down -9. So 3 different parts that you have to identify here. The first one is the center. Okay, so you identify the center. You also have to identify where the 2 vertices are. So one is at 2, not 1, and one is at over 2, -9. This is your sketch. That's your answer. Questions on how I did that? Say it again, Tina. Did you have a question?
What's that word when it says vertices are at
Farthest distance from center. That says farthest, sorry. So they're the farthest away ones from the center. Sometimes they're the side to side, sometimes they're the up and down. So you just have to look to see which ones are farther away. Okay, it's not necessarily always going to be one way or the other. Okay, next one for number 2. Again, same thing. I want you to find the center, the vertices, and sketch of 9x squared plus 25y squared equals 225. 9x squared plus 25y squared equals 225. Automatically, excuse me, what did I tell you that this is what's called standard form. What is standard form of an ellipse equal to? 1. How could I get this one equal to 1? What would I have to do? Not subtract. How are these attached here? By add, subtract, multiply, or divide? By multiplication. So how would you undo multiplication? Divide. So you're going to want to divide every single part by 225. Okay, we don't want to subtract because that's, if we subtracted, it would just create kind of more work and you'd have to complete the square, and we really don't want to do that. We'll do that in a little bit. Then we reduce. 9 over 225, these are going to go in absolutely perfectly. So this is going to give you x squared over 25 plus y squared over 25 over 225 leaves you with 9 equals 1. For this one, what would be your center? If there's no parentheses, what do you think the center is? 0, 0. There's no parentheses, has to be 0, 0. So your center is going to be at 0, 0. How far should you move side to side? To figure out how far you move side to side, what do you look at? The x denominator and take the square root. So how far would you move side to side? 5. Okay, so left and right, move 5, make a dot, and move 5, make a dot. So over 5 left, over 5 right. Label this as being 5 away. How far should you move up and down from the center? 3. Take the square root of the y denominator. So technically, these are called the major and the minor axis, okay? You don't need to worry about that. You just need to know, and if you go to advanced math, you'll have to deal with more parts of these, okay? But the vertices are at the ends of what's called the major axis. So basically, they're just at the ends of the ones that are farther away. That's all I need you to know, okay, is that they're the ones that are farther away. So would your vertices here be side to side or up and down? There's the side to sides. Okay, so you really can't tell based on just the equation. Okay, you have to look at it and figure out which ones are farther away. So what are these vertices if you label them? Is this 0, 5 or 5, 0? 5, 0. Okay, remember, we always go side to side first. So over 5, up 0, that's one vertex. Your other vertex is left 5, up 0. Okay, and those are all parts of your answer. So the center and both vertices are parts of your answer. Questions on how I did that? So I'm going to show you basically, I'm going to do one example for every different type of equation you're going to see today. The first one was just a normal one, take the square roots. Second one was when you don't have something equal to 1, how do you get it equal to 1? The next one, for number 3, is going to be what happens if everything is in the parentheses. Okay, so if you have a big parentheses with an x plus 1 over 2, and the square is over everything, not just the top. Plus, again, another big parentheses, y minus 3 over 6, and squares on the outside, and it's equal to 1. If you have where everything is in parentheses and not just the top, I want you to change it into standard form. So basically, I'm just going to rewrite the top as x plus 1 squared. Over, if I actually squared the bottom, what would my denominator be? 4. Plus, rewrite the top, y minus 3 squared. Over, if I actually square the bottom, what do I get? 36 equals 1. Now that we have it more in standard form, simple, all we're going to do is the same thing we've been doing. What would the center of this ellipse be? -1, 3. So change the sign. Then you're actually going to graph this. So left 1, up 3 is where your center's at. How far should I move on the x axis? So should I move side to side? 2. So 2 to the left, 2 to the right, 2 to the left, 2 to the right. I would label these, and just so I remember that that was 2. Sometimes if you're moving like 2 for one and 3 for another one, they look really similar, so that's why I would label these. Okay? Then up and down, how far do I move? 6, so square root here. So you're going to move down 1, 2, 3, 4, 5, 6. Remember, you're moving from the center, not from 0, 0. And then also move up 6. 2, 3, 4, 5, 6. So automatically, even before you draw this, hopefully you can tell where your vertice is going to be. Are they going to be the up and down ends or the side to side ends? Which ones are farther away? The side to side points or the up and down points? Up and down. And then you label them. So this vertex, we moved left 1. And if you move from 3, move up 6, you're going to be at 9. Here, notice that the X part, okay, like on this one, since we moved up, all these X's are going to be the same. So I had -1, -1, and then this one, if you move down 6, from 3, down another 3, gives you -1, -3. Okay, -1, -3. And those are your answers. Center, both vertices. Questions on how I did that so far? Not too bad, hopefully. Okay, next one, again, I would like you to identify the center and the vertices in sketch of 4x squared plus 16y squared minus 8x minus 96y plus 84 equals 0. 4x squared plus 16y squared minus 8x minus 96y plus 84 equals 0. What's wrong with this equation as it's written right now?
It's too long.
It is too long, yes. So it's not in standard form. Okay, so first thing you want to do is put in standard form. This is going to be where you're going to have to complete the squares. Okay, so to put in standard form, you want to put the x's together. Okay, we're going to put the x's together. You're going to put the y's together. And what else do you have to do to get it in standard form? Move the whole number to the right side. Move the whole number to the right side. Okay, so if I just rearrange this, I'm going to put the x's together. So 4x squared minus 8x. We're going to leave a little bit of space. Then put your y's together. So 16y squared minus 96y. And then finally, if I move this 84, what does it become on the right side? Negative 84. So now we're going to complete the square. Okay, to complete the square, what do we have to do? We did this last week. Take out the coefficients or the a values. So what would you take out from the x's? What are we going to take out from the x's? 4. Take out a 4. Left behind would be x squared minus 2x. Again, leave that space. What can you take out from the y's? What's the a value for the y squared? 16. Okay, you're going to take out a positive or a negative 16? Positive. That's positive still. So take out a 16. Left behind would be y squared minus, what's 96 divided by 16?
What?
Guesses?
4.
6. Okay, leave your space. Equals, we're still going to have a negative 84 here. Okay, we still want to complete the square, so you're going to take the middle number, divide it by 2 and square it. So negative 1 squared, what are you going to add inside with the x's? Negative 1 squared means you add what? Plus 1. What would I add to the opposite side, though? Say it again. Plus 4. 4 times 1. So on this side, you're actually going to add 4. Here, again, middle number divided by 2 and square it. So negative 6 divided by 2 gives you negative 3. Negative 3 squared means I add what to both sides? What am I adding inside with the y's? Negative 3 squared means you add 9. To the other side, you have to add 16 times 9. 16 times 9 is plus 144. Then if we rewrite these as completed squares, we still have a 4 on the outside. How do you write this factored? X and what goes inside with the parentheses. So negative 1, if you show your work, it's right there. Negative 1 squared plus 16 times what's going inside with the y. Negative 3, if you guys are showing your work, this should be pretty simple, equals, if you add all this together, negative 84 plus 4 plus 144, you're going to get 64. Okay, these are going to be nice numbers that are obviously going to be perfect squares. That's what we want. If you get anything that's really weird like that, it's probably a mistake. Then, just like what we did on number 2, what do I want my whole equation to equal? To be in standard form, it has to equal what? 1. So how would I get it equal to 1? Divide by 64. So divide all these parts by 64. Divide every part by 64. Then this reduces to leave you x minus 1 squared over 4 over 64 leaves us 16 plus y minus 3 squared over 16 over 64 reduces to 4 equals 1. So the first part of your answer here is just this equation. Then you have to write the center. So what is the center of this equation, or of this ellipse? Excuse me. What's the center of this ellipse? 1, 3. Then if you draw this, you're going to move over 1, up 3. Put your dot for your center. How far when I move side to side? So left and right, how far do I move? 4. Square root of the x denominator. So over 1, 2, 3, 4. Make a dot. Same thing on the right side, or the left side, excuse me. Over 1, 2, 3, and 4. Make a dot. How far do you move up and down? 2. Square root of the y denominator, so we're going to move up 2 and down 2. Connect these with an ellipse shape. Again, try to make it not look too much like a diamond. This one might be a little bit lopsided, but that's okay. Then where would your vertices be? The side to sides or the up and downs? Side to sides, and we have to label those. So this one is over 5, up 3. So this is over 5, up 3. That's one vertice, or vertex. This one is negative 3, up 3. Okay, so your center is at 1, 3. So you'll notice if you're moving side to side, the y parts of the vertices and the center are always going to be the same. So 3, 3, and 3. If you're moving up and down, the x parts are always going to be the same number. I don't expect you to memorize that necessarily, but you should at least notice it. Questions on how I got those? Yes, ma'am.
Where did you get 144?
Right here?
Yeah.
Oh, because we did 16 times 9. 16 times 9 is 144. And then the last part of what we're going to do today is I'm going to give you 4 different equations, and I'm going to ask you to identify the following. Identify the following as a parabola, circle, or ellipse. So just based on equations, we're going to identify if something is a parabola, circle, or ellipse. Okay, and I'm just going to give you 4 different equations. You're going to tell me is this an equation of a parabola, a circle, or an ellipse? Okay, so just write down x plus 2 squared plus y minus 4 squared equals 1. That's one of your equations. X plus 2 squared over 25 plus y minus 4 squared over 9 equals 1. Number 7 is going to be 3x squared plus 3y squared equals 27. Number 8 is 3x squared plus 3y equals 27. I'll give you just a second to write those down, and then we're going to figure out, are these parabolas, circles, or ellipses equations? And how do we know? Because you should be able to just look at an equation and figure out what kind of shape it is. The easiest one to look for is a parabola. A parabola only has one square. So are any of these, could this possibly be a parabola? No. Nope. Nope. This is the only one that has one square, so automatically you should be able to determine that this is a parabola equation because it only has one square. So we've eliminated parabolas. The only difference between circles and ellipses are the denominators or the coefficients. Okay, so coefficient means first, or the number in front. Okay, if the number in front or the denominator is exactly the same, it's a circle. Okay, because if you took the square root of this, what's the square root of this denominator? 1. 1. You'd be moving 1 in each direction. That makes a circle. Okay? Automatically, that's a circle. If the coefficients, so the numbers in front, or the denominators are different, you know you'd have a what kind of shape? An ellipse, because this one you'd move side to side 5, up and down 3, that's going to create an egg shape, so this is an ellipse. So again, if you have the same coefficient or same denominator, it's always a circle. Different coefficients or denominators, it's an ellipse. So what would number 7 be? Same coefficient, doesn't always have to equal 1. We would move that eventually. Same coefficient means circle. Okay, anybody have questions on how we did any of that? Homework for this is going to be worksheet 5 in your packet, and you're doing the whole thing today. You're doing 1 through 21. Anybody have questions?